Okay, so Leetcode practice time. Continuous Subarray sum. So two goals in this video. The first one is to find a solution for this specific question, do some coding work, and the other thing is to go over the interview process given the specific example. So let's take a look at the question itself. So given a list of the non-negative numbers and the target integer k, write a function to check if the array has a continuous subarray of size at least 2 that sum up to a multiple of k. Okay, so let's say given example 1, 23, 2, 4, 6, 7 as the input array, k is equal to 6, returns true because we definitely have a subarray which are 2, 4, okay, that sum up to 6. Alright, so I think I mostly understand the problem. Let's think about the edge case. So the edge case from the top of my head, for example, if k is illegal, for example, if it is 0 or if it is smaller than 0, some negative integers or 0, then what should we return? So suppose the interviewer say that those are illegal inputs and it won't appear, then that would be good. And the other thing I can think about is what if the input array is empty or contains only one number, then of course that one is going to be, we are going to return false for them. So let's say so first of all we add those edge case checking at the very beginning. So if nums.length is smaller than 2 or k is smaller than 0, then we definitely return a false here. And if k is equal to 0, then we define to return true here. Okay, so those are the edge cases. Let's step into the next thing, which is to find a solution for this specific question. So how to do it? So the first thing, which is quite brute force, is we enumerate all the subarrays and sum them up and to see if it is n times k. So this one is going to take n cubed for the runtime. If we want to optimize it, let's say we try to start from each point within this array, try to extend as much as possible, and during the time we do the extension, we will see whether the current sum is n times k. That one is going to be n squared for the runtime. So let's see if there's any other option for us to do to further decrease the runtime. Sure. So it makes me feel that it is something like a dynamic programming question, but not sure how to do that yet. Let's think for a moment. Okay, so I think I quite got it. So suppose we keep the sum. Okay, so let me explain it in this way. So first of all, we will define a map. So both key and value are of integer type. So the key of the map would be sum of subarray between 0 to the end, 0 to the end, to the current index, modular k, and the corresponding value is the index. So let's see. Let me give you an example by taking the first example provided here. Let's say suppose we have the input array looking like this. We will initialize the map with 0 minus 1 as the first pair. So why it is 0 minus 1? Because let's say we are going to take a placeholder. So if there's no number, so like we think before we iterate through this this specific input array, we see that before it the sum is because there's no number, the sum of course is 0, and then we put a placeholder for the value which is minus 1 out of range of this input array. And then we will put 23 modular 6. So here it is going to be 5, and and the corresponding index is 0. And then 23 plus 2, which is 25 modular 6. So this one, it is going to be 1, and the corresponding index is 1. And then we have 23 plus 2 plus 4, and then modular 6. So now it is 5, and the corresponding index is 2. So now it is a time we find there is already a pair within this map with key as 5, and the corresponding value previously is 0. So since it has the same value for the modular of k, then we can say that between index 0 and index 2, it is a subarray that is sum up to n times k. So so at this time we can safely say we find a subarray regardless the start index and the end index, because this question is not asking us to return the specific index. It's just asking us to return true or false. So in this case we are going to return true. Okay, so that's pretty much about the solution. And regarding the runtime, it is going to be linear linear. Suppose the length of the input array is n, then the runtime is going to be all of n. And space wise, it is going to be all of n as well. So let's give it a shot by doing some coding work. After we find a solution, it's time for us to turn our idea into solid code. Let's do some coding work on top of it. So like I said, we are going to define a map. Both key and value are integer. Let's say it is sum to index map. So we are going to iterate through the array. Okay, so before that, we are going to put a placeholder pair, which sum index map dot put 0 and -1 into it. So as we iterate through this, I is smaller than nums.length plus I. So sum is initialized is 0. So sum plus equal to nums I. So if so we are going to has to find the modular. If mode, so int, we define the mode here. Mode is defined as sum modular k. If sum index map already contains the key, key of the mode, we are going to see whether the subarray size is larger than 1. If yes, then we just return true for it. If it contains key, so if some index map dot get mod minus I is larger than if it is larger than 0. So if it is larger than 0, then it means let's see. So the sum of it, if it is larger than 0, then it means it is a subarray, but it may not make sure that it may not be able to make sure that it is a subarray with the length to be larger than 1. So if the sum index map, if it contains a mode, it means we already have something in it. Okay, so let's see if this one we are going to return true here. But we are going to fix this one after this because I haven't considered very well about this part. If it's not that, we are going to continue. Otherwise, we are going to just put this. So we are going to put some index map dot put the mode as a key and the corresponding value, which is I, in here. Okay, and finally we are going to return false. But let's try to decide if this one could be a solid condition. So I think it might not be solid because if the size is larger than 0, it cannot make sure that if it's larger than 1, I would say it's good, but if it's larger than 0, okay. So let's take a look at this example. If we have that as, okay, so when we find 23, 2 and 4, so we find 23, 2, 4. So okay, so that's the time we find another 5 there. If we find another 5, it should be larger than 1. Okay. Okay. Yeah, it should be larger than 1, then it should be good. Then let's go through this. So after we finish the code, it's time for us to do some testing. So for the testing part, we are going to go through a example to do some sanity check, and at the same time we are going to explain how this piece of code is going to work. So we have already explained that the edge cases, and then let's directly go into this general logic by using this piece of code. By using this input example, let's say we have the input as 23, 2, 4, 6, and 7, and k is equal to 6. So at the very beginning, we are going to initialize some index map, the same as 0 and -1. So as we iterate through this input array, we are going to insert new things into this sum index map. So currently, when I is equal to 0, the sum is equal to 23, and mod is 23 mod 6, which is 5. And since the index map is empty, we are going to put 5 0 into this map, and continue. We are going to put 1 and 1 into it, and when we encounter the third element in the input array, we see that the sum is 29. So 29 mod 6 is equal to 5 again. So we encounter another 5, and we see the current index I is equal to 2, is equal to 0, 1, 2, is equal to 2. So 2 minus 0 is larger than 1, then we return true. Okay, so I think it should work in general. As other test cases, we can set up other test cases. For example, we can set test cases like those edge cases, and also something like if we only contain a number, if we only have we can if for the input array there is only single number Subarray that can be n times k. So for example, if it is 5 and 6 and k set up as 6, is it going to return true or false? This would be another good test cases to set up. So other than that, I think we should be good to go. So let's give it a shot by running this piece of code. Okay, some compile, some typo here. Okay, so it is wrong answer. So 232467. Why it is giving us false? Let's see. So first of all, we are going sum is plus equal to nums I. Let's go through this piece of code again. So at the very beginning, we put 0 and minus 1 here. Sum is equal to 0. So sum plus equal to nums I, which is 23. So 23 modular 6, which is 5, and mode is 5. And the map is empty here. Now we put the 5 and 0 into it, and then when I is equal to 1, then so now sum is equal to 23. So when I is equal to 1, then sum is equal to 25. So mode is 25 mode k, which is 1. 1 of course is not in the map. We are going to put 1 and the corresponding value as 1 here. Okay, so now when I is equal to 2, we are going to have sum as 29. Alright, so 29, the modular 26 mod 6, 29 mod 6 is equal to 5. So mode is 5, and we already contain 5 in this one. Oh, sorry, this is a typo here. It should be I minus this one. Yeah, so this is so I think I wasn't typing as what I was thinking. So now it is accepted. Let's submit this piece of code. Okay, it's another wrong answer. So what if it is minus 6? So if it is minus 6, output is false. Oh, okay. So that's, I think we just misunderstand what we define as edge case. So actually, for minus 6, we also consider it to be some valid input. So that's our misunderstanding. And also if output, if the input is 0, then so if k is equal to 0, then we shouldn't return true for it. Okay, so that's another misunderstanding about it. Alright, so how to... so if it is 0, then we are not going to return we are not going to blindly return true for it. So instead we are going to return... so if it is a 0, then we should return false based on the based on this decision. So if it is 0, then we should return a... so if it's 0, 0 as the input array and the return value is, and the k is defined as 0, then output is, we should return true for it. So now I think I understand how to deal with when k is equal to 0. So int sum is equal to +1. Int mode is k, if k is equal to 0. If it is equal to 0, then mode should be 0. Yeah, so in this case, I think, let me see if it is going to work. So if sum index, we put 0 as value -1 is here. Okay, so sum is always equal to 0. If k is equal to 0, we just put 0 instead of modular it. And if I is equal, otherwise we continue. Otherwise we just continue. Okay, so let's give it another try. Okay, yeah, so it is some misunderstanding about what to return in some hash cases. So in this case, it is still returning the wrong answer. Why? It is because so this is becoming more confusing to me. So if 23, 2, 6, and 4, 7, and the return and the given k as equal to 0, currently we are giving the output as true, but actually it is expecting false. That is because so if there's any subarray that sum up to 0, it should be that. That's essentially what it is asking us to do. Interesting. So if it is equal to 0, then essentially we need to see if there is any continuous zeros there. Okay, so if it's equal to k is equal to, so modular sum. So actually if k is equal to 0, we need to do some special things. If k is equal to 0, we will see if there is any continuous thing. So int int I is equal to 0, I smaller than nums dot length -1 plus I. So if nums I plus num, because it's non-negative integers, plus nums I plus 1 is equal to 0, then we return true. Otherwise, at the end we should return false. Okay, so let's submit this again. So now it is accepted. Okay, so actually we misunderstand the special task case, which is k equal to 0. So if it's k equal to 0, it asks to do something like, if there is a subarray sum up to 0, we return true, otherwise we return false. So that's exactly what it asks, what we are trying to do in the first step to think about edge case. We need to clarify the edge cases clearly with our interviewer. So at the very beginning, we just think that we can blindly return true, but it's not true based on the setup of the task cases in this specific example. Yeah, so that's a lesson we learned, but it's a good thing because we notice the importance of clarifying the edge case at the very beginning. And sure, so that's it for this coding question. I hope you find this a little bit helpful during the time you prepare your technical interview. So thanks for watching it, and I'll see you next time.